Lesson 5.5, using multiplicative inverses to solve equations. The title is intimidating sounding, but we know multiplicative inverses by another name. From the last lesson, we know multiplicative inverses by what we call reciprocals. They're the same thing. Multiplicative inverses and reciprocals mean the same thing. So what I want to do is I want to consider two types of problems that involve multiplication, two types of equations to solve. This type of equation we've already solved before. We have an integer 4 times x is equal to 16. This one over here, we have a fraction. 4/5 times x is equal to 16. We solved this one by doing the inverse operation. We are multiplying by 4. The inverse of multiplying by 4 would be to divide by 4. So we divided both sides by 4 to come up with our answer. 4 is canceled. That's why we did the inverse operation, and 16 divided by 4 is 4. Now, if I use that same logic over here, I've got to divide by the number that's times the x. Well, I would be dividing by 4/5. Now remember, dividing by 4/5 means the same thing as multiplying, multiplying twice, multiplying by the reciprocal, 5/4. So instead of trying to divide by a fraction, we're going to just kind of cut out the middle step here. We're going to change the dividing by a fraction to multiplying by the reciprocal. And that brings in the multiplicative inverse property, or the inverse property of multiplication, which says that the product of a number and its reciprocal is 1. See, a over b times b over a, these are reciprocals, and you get 1, provided that a is not equal to 0, b is not equal to 0, because of course you can have 0 in the denominator. So what we're going to do is we're going to use this key idea right here, that dividing by a fraction is the same as multiplying by the reciprocal. Look at my first example. I'm going to solve this equation. 2/3 m equals 36. The 2/3 is times the m. So since something is times it, we've got to do division, but since it's a fraction, we're going to multiply by the reciprocal. The reciprocal of the number times m is 3/2, because this is 2/3, so 3/2. So I'm going to multiply both sides by 3/2, because remember, whatever you do to one side of the equation, you have to do to the other side of the equation. So I have 3/2 times 2/3 m, and I have 3/2 times 36. You can see I just brought the sides down, and I'm multiplying both by 3/2. Well, these are reciprocals. Just like here, this should be 1. These cross cancel, these cross cancel. That's why I did all that. Now, I'm not going to do this step every time. I'm just going to go right to the fact that this is 1m or m. However, on the other side of my equal signs, I have 3/2 times 36, and we know we need to put that 36 over 1. And I can cross cancel here a little bit. 2 goes in that once, 2 goes in that 18 times. 3 times 18 is 54. All over 1 is 54. And there's my answer. I wish there was an easier way to show you this, but when you're working with fractions, sometimes you got to get a little, dirty with fractions. You got to get into this stuff a little bit. You're going to have to do some arithmetic. The next example, very similar to the first one, except for the negative. Negative 7/8 k is equal to 56. The negative 7/8 is times k. So I've got to get rid of that, and that's where I'm going to use the reciprocal idea. I'm going to multiply both sides by the reciprocal of negative 7/8, which would be negative 8/7. I'm going to multiply this side by negative 8/7. I'm going to multiply this side by negative 8/7. This times this is just 1. These are reciprocal, so I have 1k or k. On the right side, I have a negative times a positive. That's going to be negative. I'll put the 56 over 1. 7 goes in that 1. 7 goes in that 8 times. 8 times 8 over 1 times 1. 64 over 1, or just 64. K equals negative 64 is my answer. Now, the third example I don't have an integer on the right side. I do have a fraction times my variable, but I have a fraction on my right side. It doesn't matter. It's just going to involve the arithmetic when I multiply by the reciprocal. And the reciprocal of this fraction, the one that's times the x. If this was on the right side, it would still work the same way. Whatever it is that's times the variable, that's the one whose reciprocal I'm going to use, not the reciprocal of the right side. In this case, negative 9/17, the reciprocal is negative 17/9. I'm going to multiply both sides. If I left myself enough room, I am anyway. Negative 17/9 times negative 9/17 right here. That's just 1. These are reciprocals. When you multiply reciprocals, you get 1. That's this property here. And 1x is x. Now on the right side, I have a negative times a positive. So I know that's negative, and I have some cross canceling here. This is convenient. The 17s cancel. And a 3 and a 9, 3 goes in that once, and to that 3 times. So I have 1 times 1 on top, 3 times 1 on the bottom. That's 1/3. And there's my answer. X equals negative 1/3. Now we'll consider some two-step equations that involve a fraction times the variable. My first example, my variable is on the right side this time, and it's being multiplied by 3/4. But there's a 20 that's being subtracted from that expression. So this is a two-step equation. There are two things I have to do. I have to get rid of the 20. I have to get rid of the 3/4. Now we remember, hopefully we remember, if not I'm going to remind you, that when we're solving a two-step equation, unless the whole side's a big old fraction, which is not the case here, you undo the adding or subtracting step first. So I'm going to get rid of the minus 20. And the inverse of subtracting 20 would be to add 20 to both sides. So I'm going to add 20 to both sides. Just write it like the shortcut here. Negative 16 and a positive 20 is a positive 4. These are going to cancel out, and I get 3/4 n. Now this one should look a little bit like the problems I was just doing before. I have a fraction times my variable. I'm going to multiply both sides by the reciprocal. The reciprocal of 3/4 is 4/3. So I'm going to multiply 4/3 times 4 and 4/3 times 3/4 n. These are reciprocals. When you multiply them, you just get 1 or 1n or just n. And on this side, because the 4 is written as it's an integer form, I'm going to write it as a rational number, as a fraction, by putting it over 1. And I get 16 all over 3. 16 all over 3 is not the world's worst way to leave your answer, but it is an improper fraction. So just remember that this is the same as 5 1/3. 5 1/3. 3 goes in 16 5 times with 1 left over. The next example, I have fractions all the way through, so that's a little intimidating. What I'm going to do is I'm going to solve, in this case for x, I have to get rid of the 2/5 that's times the x and the 1/5 that's being added. So just like before, when something is added, we're going to subtract to undo. Something subtracted, we're going to add to undo. We have to undo the adding or subtracting step first. So I'm going to get rid of the plus 1/5, and I'm going to write it out the standard way by subtracting 1/5 from both sides. Now we catch a break. On the right side, they have common denominators. So that's going to work out nicely. I get 2/5 x is equal to 2/5 minus 1/5 is 1/5. Almost done here. I'm going to get rid of the 2/5 that's times the x by multiplying by the reciprocal, which is 5 over 2. Both sides, 5 over 2. These are reciprocals. You multiply, you get 1x or x. Now over here I can cross cancel a 5 and I get 1/2. This example, more of the same. I've got fractions all the way through. My variable x is right here. It's being multiplied by negative 2/3, and there's a half being added to it. I'm going to subtract the half from both sides. And again, I catch a break here because on the right side they already have common denominators. These are going to cancel. I get negative 2/3 x. Here I have 5 halves minus 1/2. Subtract the numerators. That's 4 halves, which is 2. This is going to be 4 halves, and 4 halves simplifies to 2. Now I'm going to get rid of the negative 2/3 that's times the x by multiplying by the reciprocal. You should be seeing this as you write the problems out. You should see that next step coming. Negative 3/2 times 2. These are reciprocals. That's just 1x. And over here, I have negative 3/2 times 2. I'll put the 2 over 1. I can even simplify by cross-canceling the factor of 2. In this numerator and this denominator, that gives me negative times positive, negative 3 all over 1, which is negative 3. And my answer is x equals negative 3. My last example, I saved the best for last. I have two-step equation, and I have fractions all the way through, but notice none of the denominators are the same. So I might have to do a little least common denominator step here. I'm going to solve for g. I have to get rid of the 3/8 that's times it, and I have to get rid of the 1/2 that's being added. I get rid of the 1/2 first. You always undo the adding or subtracting. To get rid of a plus 1/2, I am going to subtract 1/2 from both sides. And here's where the fun begins, because now you are expected to remember how to do this arithmetic. You must get a common denominator. So I'm going to do a little scratch work right here. It's my scratch paper. I'm going to take 13 over 16 minus 1/2. My common denominator, since 16 is a multiple of 2, is 16. This stays the same, so this stays the same. To make a 2 into a 16, you multiply by 8. I got to multiply the top by 8. So now I can subtract the numerators. 13 minus 8 is 5, and put that all over the common denominator. It doesn't simplify. I get 5/16. So all of this is 5/16. These cancel out, and I get 3/8 g on the right side. To get rid of the 3/8 that's times the g, I'm going to use the reciprocal, which is 8/3. I'm going to multiply both sides by 8/3. Now, 8/3 times 5/16, I can cross cancel an 8. Goes like that. I end up with 5 over 6. And of course, these are reciprocals. That's just 1g or g, and there's my answer. It takes a little bit of practice, and in the next lesson, I'm going to show you an alternate way to solve equations like this by eliminating the fractions, which will probably appeal to some. But we want to make sure we know how to do them this way also. So remember, practice, practice, practice.